Asyle, Tropical Island Survival. Week 32, Day 1. This is my last week to prepare for what I can only presume to be the next smuggler incursion. After my morning chores, I got some bamboo and claycrete and finally sealed up that tiny entrance at the northern end of the tunnel complex. However, I found that I couldn't resist making it into a puzzle as well, though one that could only be solved from inside the tunnel, namely by drilling holes in bamboo bars and jointing them together such that you have to slide the bars through each other in a particular order to open the grate. This would keep anyone from getting in from outside and slow down any pursuers who might be trying to follow me out, but it wouldn't slow me down because I know the correct order. To make sure I wouldn't forget, though, I scratched some marks into the bamboo, and because I'm a massive nerd, I used Denis numerals to mark out the order, which I suspected most people weren't even going to know, much less have memorized. This exercise only took me a couple of hours to build the bars and set the concrete, which brought me back to thinking about ways to evade or repel attackers. Honestly, diving into that submerged tunnel when I was working on the hydrophone absolutely captivated my imagination. And though I was distracted for a while, getting back out on the boat, seeing the reef below through the crystal clear water, and naming my boat the Diving Spider have only reinvigorated my interest in the ocean. I'm starting to come up with a scheme to build an honest-to-goodness diving suit, both to allow me to explore the reef, as well as to give me one final route of escape to someplace the smugglers can't follow me. It would be a tight squeeze for time, but I already have some of the materials I need for the suit, in the form of the surplus rubberized sailcloth. I could probably make a steel diving helmet via electrolysis if I have enough iron, though I'd want to make sure I did the engineering on it. Whatever I make, I'll probably want to case harden it as well, like my shotgun barrel, since pure iron is soft and carbon steel would be much more pressure resistant. However, I don't know the compressive strength of this steel, so in the absence of a better means of testing it, I found something relatively hard and pointy, like a grain of sand, with a surface area of about 1 square millimeter, and tried to balance increasingly heavy weights on top of it until a divot formed in my shotgun barrel. More often, this just crushed the piece of sand, so I eventually just rested a rock on top of the shotgun barrel, and once a divot formed, I measured its area approximately. This was an extremely crude method of measuring compressive strength, but as far as I could tell, it was at least mathematically valid. I got a divot of measurable size, and an applied weight of about 25 kilograms, which was kind of impressive, giving the steel a compressive strength of about 250 megapascals. Now for the engineering. The amount of force that'll be pressing on a given area of the helmet will be equal to the surrounding water pressure times the cross-sectional area of the helmet. Force equals pressure times pi times radius squared. Resisting that force in equal and opposite measure will be the compressive strength of the steel, which will be multiplied by how much of it there is to do the resisting. Force equals the strength of the steel times pi times the thickness of the steel times the quantity 2 times radius minus thickness. Rearranging all that with some algebra, we get the equation strength equals pressure times radius squared divided by the quantity thickness times the quantity 2 times radius minus thickness. If the helmet needs to be at least 30 centimeters in diameter to fit my head in, and I give the helmet a thickness of about 1 millimeter, since I can't solve for thickness with this equation, the pressure it would be able to resist would be about 3.32 megapascals of pressure, or a depth of about 338 meters below sea level, which is way overkill, so I should be okay no matter how thick I make the helmet, so long as I make sure the viewports I install in it are secure. The complicated part, however, is going to be making a breathing apparatus. I've already got the potassium peroxide air bladder I built the other day, but that's not going to work by itself for a diving suit, for several reasons. The first is that, while it may give me oxygen, it does nothing to get rid of the carbon dioxide I exhale. Both of these problems would be fixed automatically if I could make potassium superoxide, which scrubs CO2 and turns it directly back into oxygen. However, as I've discovered, it's not as easy as throwing the components together in the same pot. It's an unstable chemical, evidenced by the fact that it actually explodes if it comes into contact with water, another issue I'd have to solve, so it needs very high temperatures and pressures to coax it into this form. I might be able to pull it off with my pressure cooker, but part of the problem with that will be filling the cooker with pure oxygen, which I can only store in rubber balloons right now, which wouldn't resist the back pressure from the pressure cooker. I racked my brain a little on this, and concluded that if I add a little water to some of the potassium peroxide before closing the pressure cooker, it would fill the chamber with pressurized oxygen. Even if it reverses the reaction a little, it's not going to change the fact that oxygen gas must be produced to keep the chemistry balanced, which will force it to be absorbed by the rest of the potassium peroxide. That is, the water shouldn't vaporize out of the resulting potassium hydroxide and ruin the reaction. With that figured out, the use of a dual oxygen producer / CO2 scrubber should also help with the second problem of maintaining a specific pressure differential. If the air inside the suit were maintained at atmospheric pressure, the surrounding water pressure would crush me and I wouldn't have the strength to breathe. The exchange of gases within the scrubber should minimize the problem of pressure building up or dropping with each breath, as would be the case if I were just venting my CO2 like with scuba gear. But this doesn't address the problem of the water pressure increasing the deeper I dive. This can be counteracted by either increasing the pressure of the air I'm breathing to match the outside water pressure, which can cause issues like the bends from nitrogen bubbles forming in my blood and oxygen toxicity at higher pressures, or by reinforcing the suit, particularly around the chest, so that it resists the water pressure physically. Probably some combination of the two. I could make some kind of compressed air tank to act as a reservoir for equalizing the pressure with depth, but I definitely don't have enough iron to make something like a scuba tank. I may not need to, however. If I use something that changes in size, like a balloon, the water around me will squeeze on it until the pressure inside the balloon, and by extension my dive suit, equals the pressure of the ocean around me. A big balloon on my back would be cumbersome, though, and probably keep me from sinking in the water, which is why scuba tanks use pressurized air and a regulator to keep the pressure right. However, it occurs to me that the pressure resistance of an air tank is only due to the tank's tensile strength, and I have access to plenty of materials with high tensile strength, particularly bamboo, so perhaps I could make something like a balloon wrapped in cord, like a big ball of twine, where the cord would allow it to store gases at relatively high pressure. I'd need to test this, and I'd need a pump to increase the air pressure. I'm not sure if my diaphragm pumps are necessarily up to the task. Something worth experimenting with. Even if they aren't, a simple rubber balloon should be adequate for shallow dives. After a couple of hours, I had what seemed like a good place to start, but by the time I was done with all the tests and plans, it was time for lunch, so I ate before getting started with the project. The part I expected would take the longest was electroplating the helmet, but before I could do that, I needed a form for it to electroplate onto. So I started by making an unusually shaped clay pot, as close to perfectly spherical as I could get, with a wide neck, just about big enough to fit my head inside, and with some odd circular plugs sticking out at different angles. This will be what I form my helmet around, the plugs marking the places for the windows later. For the time being, I simply left it to dry in the sun. The next hardest part was the breathing apparatus, and frankly, the part I needed to get the kinks out of first, as it was the only component of the suit I actually needed for diving. For something that complicated, it was actually kind of hard to know where to start, but I figured it would probably be with synthesizing the oxygen scrubber. Over the past few months, I've been stockpiling potassium peroxide, though not a great deal of it because I wasn't too serious about its production, and since I didn't have a lot of ideas for what I could do with it until now. Still, I had enough to start experimenting with and testing the potassium superoxide manufacturing technique. As planned, I opened up with the pressure cooker, giving the steam a few minutes to clear out before loading the chemicals into it. As I understand it, the reaction between potassium peroxide and water produces 1 molecule of oxygen and 1 molecule of potassium hydroxide, and 1 molecule of oxygen plus 1 molecule of potassium peroxide should produce 2 molecules of potassium superoxide. So I loaded equal molar quantities of water and potassium peroxide into some narrow pieces of bamboo, the water being held in the bottom chamber and the potassium peroxide at the top. When the water gets hot, it should evaporate out and react with the potassium peroxide to create oxygen, but little to none of the water should make it out of the tubes unreacted, so as not to spoil the rest of the reaction. I then spread an equal part of potassium peroxide on the inside of the pressure cooker to expose as much of the potassium peroxide surface to the hot oxygen as possible. Now, I'm pretty confident that this is not the way this reaction is supposed to be done. This isn't the way the reaction wants to be done. However, my understanding of chemistry is that, given enough energy, the unstable molecules you want will eventually form, given the right materials. It's basically bumping those molecules up to a higher state of potential energy, like lifting a weight or coiling a spring. And the new molecular form is like a shelf that weight can be rested on, even if the shelf is a little unstable. I didn't know how much pressure or how much heat I would need, but I decided to go for the max, sealing up all the outlets on the pressure cooker and adding some fuel to the kiln and air from the bellows to get it extra hot. Once I was done loading everything back into the kiln, there wasn't a lot I could do but wait and keep the fire burning, at least until the end of the day. Next, I started prototyping the breathing apparatus, and because I didn't necessarily want to lose all of my air if the suit or helmet failed, I decided to make something more like a scuba apparatus with a mouthpiece and everything that I could still hold on to with my lips and teeth in case something went wrong. This was fairly simple to mock up with bamboo, making a simple T-joint that I could even put one-way valves on either end of, so as to make sure only bad air went out and only good air came in. Once I was done carving it to my satisfaction, I coated it in rubber and made some hoses and a pair of similar valves at the ends to go with it. Coating the mouthpiece in rubber gave it a bitter taste, but also made it easier for me to maintain a good seal on it with my mouth. Next, I needed to construct something to hold the scrubber powder while still letting my breath diffuse through, and this is where I ran into a few hard constraints to help me anchor the design. I remembered calculating a long time ago for a different project, I was designing a spacesuit for my own amusement, that a 1/4 cup of potassium superoxide would give someone about an hour of breathable air, depending on how hard they were exerting themselves. That by itself meant I could build a pretty capable breathing apparatus with not much more than a short stick of bamboo to conduct a relatively long dive. However, I wanted to have more than that, and not simply as a personal safety buffer when diving. If I'm going to rely on this thing as a last-ditch means of escape to somewhere the smugglers can't reach me, I was going to need to outlast them. They'll expect me to come back to land, or at least the surface for air, eventually. And if I don't, they're probably going to think I drowned, or will at least give up waiting for me after a certain amount of time, 24 hours at the most, which would mean 6 cups of potassium superoxide, which still doesn't seem like a whole lot. I decided to make several modules for storing the scrubber, similar to the rods I made for the pressure cooker reaction. The difference with these, however, was that on the intake side of the module, I put a chamber that was filled firstly with salt. This was to dehydrate the air that I'll exhale, so the water vapor won't react with the scrubber, potentially causing an explosion. Above that, I made a chamber for the superoxide, and at each partition or cap in the scrubber rod, I put a small scrap of cloth to keep the powders from spilling out, while still allowing air to flow through them freely. I ended up making a T-junction at the bottom of the rod and attaching a small balloon to it as a sort of pressure capacitor for maintaining an equal pressure with the rest of the water, and I added some more rubber membranes for one-way airflow. I started getting some ideas for safety mechanisms to close off the module in case of a leak or isolate it in the event of an explosion, but I didn't have time at the end of the day to test these ideas further. Suffice it to say, I have the foundation for a simple but versatile air scrubber module, and my plan is to build several in parallel, so my lungs won't have to work as hard pushing air through all that powder. Distributing the airflow between more modules will mean a larger surface area for diffusion, meaning lower flow rates and pressure requirements in general. I'm curious to know if my potassium superoxide reaction worked, but it's getting dark. I figure it'll keep, so I'll let it cool overnight and check it again in the morning. Week 32, Day 2. I checked on the potassium superoxide first thing in the morning, and I wasn't really sure what to expect. If it hadn't reacted, I would have to find another solution for my oxygen scrubbing problem, possibly even resorting to find a way to produce pure potassium metal via electrolysis, but without water. It seems as though the reaction did work, but only to a limited degree. I suspect I didn't use quite as much water in the reaction as I should have, as a great deal of the oxygen produced by the reaction probably remained floating around inside the pressure cooker, rather than soaking into the potassium peroxide strewn within it. But I was being conservative. The resulting powder, when tested by adding a little water to it, bubbled much more vigorously than the potassium peroxide, but didn't quite explode like I was expecting, leading me to suspect my error. I didn't have enough potassium peroxide to try again, so I took what impure potassium superoxide I had to begin testing with, and put my helmet pot in the kiln to cook for the day. In the meantime, I decided I needed to switch potassium peroxide production into high gear. It would have really helped if I could have done my electrolysis in the lab rather than the workshop, but I didn't want to waste wire, so instead, after my morning chores, I moved my bubbler rig and calorimeter stove into the workshop and directly connected it to the electrolysis tub. I started a little fire in the stove to help drive the reaction, and I'll have to keep an eye on it throughout the day. For fun, I also connected a balloon to the opposite side of the electrolysis cell to collect the hydrogen gas produced there. I then got back to my breathing apparatus, assembling the hoses, mouthpiece, and now filled scrubber module into a single closed system. I made a few tweaks first though, making additional junctions and caps to cover them, so I could add more scrubber modules later. I also added a rubber ball that'll float to the salt side of the scrubber, so that if the system ever started filling with water, the float would plug the scrubber up before the water had a chance to get into the scrubber. I put a similar mechanism at the scrubber end of the module, so that if the scrubber does explode, the rubber ball will shoot up into the manifold and plug the passage, preventing the rest of the manifold from flooding. The balls will be held in place by the inevitable pressure differential between water and air in the system, but it'll only work as long as the modules are kept upright. Once these tweaks were done, I tested it by using it to breathe while I got on with the rest of my tasks. coating it with a little soapy water so I could see where there were any leaks by the presence of bubbles. Because I had to use my lungs as the pumps, it did make it harder to breathe, like I was constantly inflating a balloon. However, I wasn't doing anything strenuous, so I was able to keep up with it and effectively exercise my intercostal muscles and diaphragm for this activity. In the meantime, I started working on the diving suit itself. I was aware as I was working on it that the suit wasn't strictly necessary, as I could just go diving with the apparatus I had on. But it occurred to me that, because my scrubber modules were so small, I could wear them inside the diving suit itself as an extra layer of protection from the water surrounding them. Otherwise, the whole getup with the suit and helmet are pretty much for my personal comfort while diving. This concept of keeping the scrubbers inside the suit caused me to take the design of the diving suit in a different direction, and to postpone cutting the sailcloth into shape. Instead, I started working on building a larger manifold for the scrubber modules, bending them so that they formed a cylindrical cage, the idea being that the scrubber manifold would double as a pressure cage for protecting my chest while diving. The result actually looked kind of like a rib cage, which I expect will absolutely make me look like a Scooby-Doo monster by the time this thing is finished. I was only able to finish the frame of the manifold before lunch, and near the end of that activity, after a little under an hour of testing, I started having difficulty breathing, suggesting to me that the impure potassium superoxide had finally run out. I literally took a breather over lunch before getting back to the manifold. I had to tweak the safety mechanisms a bit, since the scrubber modules would no longer be vertical. Instead, I drilled holes in the bamboo partitions near the top of the apparatus and used a rubber membrane with a small float glued to it to close up the modules if they start filling with water. And I put several such flood prevention valves in the sternum of the manifold to keep the modules compartmentalized in the event of flooding. That is, if one module floods, I can still use the others to get to shore. The explosion protection still worked the same way, though. By that time, the helmet pot had finished cooking, so I removed it from the kiln and left it to cool before getting back to my diving suit. Another benefit of the compact scrubber apparatus, I realize, is that it leaves my entire back, where the breathing apparatus would normally be situated, completely free for the pressure balloon. In part, the suit can perform that function by itself, for shallow dives at least, but a larger collapsible volume would be needed for going any deeper. For this purpose, I painted rubber onto some of my larger pots, which I would have to sacrifice later, to make a couple of thick balloons. As I went, I wrapped them in bamboo cord so they could store air at elevated pressures when they were finished. This took a few hours to get the layers thick enough to where I was reasonably confident they'd be safe against rupture. By making several of them, 6 to be exact, I again protected myself with redundancy in case one of them fails during a dive. I then constructed a manifold to connect them to on the salt side of the scrubber manifold, so I'll be filling them up with each exhalation, while they provide pressure to the system when I stop. I built flooding protection valves into this manifold as well, and by basically staggering them with scrubber manifolds, they should again be able to continue functioning individually if one or more of them fails. Again, it wasn't quite finished when I reached the end of the day, and I'll have to pick it up again in the morning. As I was tidying up, I coated the helmet jar in carbon where I wanted the iron to grow on it, and installed it in the electrolysis tub before reversing the polarity on the whole thing. By this time, all of the iron ore has been electroplated, and the resulting plates have been doing little except creating hydrogen and oxygen. By reversing the polarity on the tub, now the iron that's already plated should move on to the helmet. I remembered to switch the hoses connected to the bubbler apparatus and to stoke the fire under it before turning in for the night. Week 32, Day 3. In the morning, I collected my potassium peroxide and loaded it into the pressure cooker before the kiln had a chance to get hot, this time correcting my mistake and leaving more of it to make oxygen gas for the reaction. I decided this time to leave it cooking at a lower temperature, but for a longer time, to see if that helps or lets me get away with using less firewood. I reloaded the bubbler to continue oxygen production, and then did my morning chores before getting back to the pressure manifold. I built a couple of diaphragm pumps, some hoses, and a couple of valves which I connected to my pressure manifold. The idea with these was that I could use them to pressurize the air in my tanks, putting the pumps in the boots of the suit to make the operation easy. Left to themselves, though, the air tanks would just inflate my suit until the pressure equalized. But I couldn't really use a rubber one-way valve to keep the air in, otherwise I couldn't access that air either. Instead, I decided to just use a simple valve that I can adjust manually as I feel my suit starting to compress during descent. Then during ascent, I can turn the foot pump valve back on to pump air back into the tanks and keep the suit from inflating. I like how everything the suit needs in order to be fully operational is built into it, rather than being dependent on a whole bunch of external paraphernalia. A singular, compact, self-sufficient package, which I suppose is a personal ideal for myself as well. I needed to wait a while for the latex to set, however, so in the meantime, I finally started working on cutting out the rubber dive suit from my spare sailcloth, since I had a better idea at that point of the measurements I needed. I found myself running into another little problem, however. If it were a pure rubber dive suit, I might have been able to make it in one piece and insert myself into it through the neck. But this material has cloth reinforcement, so I have to come up with a way to get in and out while still making the suit waterproof. The only way I can think of to make entry to the suit practical is to split it at the waist, but to keep it watertight will take some thinking. I basically have to make a tight rubber seal at that seam, which will require something pressing hard from the outside and something resisting that pressure from the inside. After racking my brains on it for a while, what I came up with was a couple of bamboo hoops to be installed at the waist of the trousers on the inside. Then at the hem of the torso of the dive suit, I'll have a belt made from rubber-coated bamboo cord or rope, which I can twist or lever taut and lock in place so there's no risk of it coming undone during a dive. This will create a tight rubber seal between the two pieces, which water shouldn't be able to get through, and I can use the same mechanism to seal around the helmet too. With that figured out, I set about cutting, hemming, and sewing my rubber suit together. I made a few open plugs along the spine so that the scrubber manifold on the inside could connect to the pressure manifold on the outside of the suit, and I sealed the connection with a liberal amount of rubber. Kind of looks like spinal ridges poking out. Once everything was pretty much done, I gave the sailcloth an extra coating of rubber to make absolutely sure it was watertight before hanging it out to dry and having my lunch break. While I was eating, I thought about what else could be a problem with this diving suit. One major problem I'd been thinking about since making the pressure tanks was the fact that this suit would be super buoyant. Normally, these kinds of suits would be weighted down with lead on the shoes and around the waist, but I didn't have enough lead for that purpose, and I didn't want to bother mining for it this week. It was probably too late, and it's much more useful to me for other things, like batteries. I considered what heavy things I did have access to, and that basically came down to clay and concrete. So the idea I came up with was to make a set of tiles, similar to the ones I made for the suit of armor, and use them to cover the surface of the diving suit. This would not only distribute the weight of the suit evenly across its whole surface, so I wouldn't feel like it was just my feet that were being weighed down, making my legs work extra hard, but would more importantly protect the suit from punctures from rocks and coral, perhaps even sharks or bullets if I'm slow in escaping the tunnel. With that in mind, I started working on another round of tiles, which seemed pretty mundane compared to all the other cool stuff I'd been designing and building this week, before leaving them out to dry in the afternoon sun. I was surprised that I'd actually kind of run out of things to do for this project, at least anything pressing, as most of the important components were either drying, cooking, or plating. The only other thing left that I could think of was to start cutting out the glass panes for the helmet. In the old-timey diving helmets, they'd be sandwiched between two rings of brass and bolted together, but I didn't have the materials or tools to make something like that. Instead, my plan was pretty much to glue them in place with latex and let the pressure of the water outside hold them down. This wouldn't work, of course, if I let the pressure in my suit get too high, which could blow them off and/or let water in. So I made a simple bamboo frame to surround the panes, which I could hold tight against the helmet with twisted bamboo cord. Best I could do under the circumstances, I suppose. I started cutting one of my panes with the flat lens cutter, using some ash paste for an abrasive. I designed the viewports in my helmet to follow a hexagonal pattern about the front of the helmet, to give me a full view of everything in front of me, with a nice, wide view up, down, and to the sides. The hexagonal framework should also be quite strong, and fits well already with the hexagonal glass panes, which I simply subdivided into 7 smaller lenses. While the lenses ground down, I worked on the holding frame for them, and between attending to the lenses, I basically spent the remainder of the evening checking and tweaking the diving equipment I've built so far. Among other things, thinking about the risk of overpressurizing the suit gave me the idea to make an automatic bleed valve, just a simple one-way rubber membrane to the outside of the suit, so that if the suit did start to reach a pressure higher than the surrounding ocean water, bubbles would come out and I would see them and know I had to make an adjustment. Another thing I did was make sure there was room inside the finished diving apparatus for my original test scrubber. The idea being that even if the entire scrubber system fails or runs out while I'm diving, I'll still have the original sitting right next to my head as a backup, giving me at least an hour to get back to shore. I continued fiddling with these parts until the end of the day, when I removed my, hopefully, potassium superoxide powder from the kiln, now that no more cooking would be happening. This round seemed more successful, making about 2 cups of superoxide, which I tested, producing a much more potent explosion when exposed to water. With that determined, I loaded the powder and a fraction of the mountain of dehydrated salt I'd made from desalination all these months into a couple of my scrubber modules, particularly the test apparatus, which I'd like to try testing in the water tomorrow. Week 32, Day 4. I wanted to make more potassium superoxide when I got up in the morning, but I decided it was more pressing, pardon the pun, for me to use a pressure cooker to vulcanize all of the now dry rubber parts of the suit, so that they would be as strong and puncture resistant as possible when I have to take them underwater. So I loaded them into the pressure cooker first thing in the morning, though this also presented me with another conflict of interest regarding the clay tiles I made yesterday, which were now ready for baking. So after my morning chores, I sacrificed a bit of wood to cook them in the kitchen kiln for the day. I've also been trying to stockpile wood as much as possible, because it's starting to weigh more and more on my mind that the rainy season is coming. And when it does, I won't be able to use the solar kiln as much anymore, and it'll be harder to find nice, dry firewood, limiting my cooking and construction options. I then got on with my morning chores, and considered what to do next when I got back. Once again, there wasn't a lot I could do for the suit itself right away, but it occurred to me that there were some peripheral pieces of equipment I could create to make diving easier and more interesting, particularly if I decided to start doing stuff down there. In particular, I expected I would need to see in the dark, especially down that long tunnel, or if I decided to go diving at night to study the reef under those conditions. So I spent some time adding some extra rubber seal to my headlamp, which should otherwise work just as well underwater as on land. I also used a bit of the leftover sailcloth scraps to make a sort of laundry bag for carrying specimens or equipment underwater. This will be especially valuable if I'm collecting marine animal or plant specimens to study, which I'll need to keep wet if I transport them out of the ocean and into my base. When I was done with these light projects, I decided to start my open water test of the breathing apparatus, carefully at first, gently immersing it before swimming around with it in the shallows while looking through the water below me. I then loaded my diving equipment onto the catamaran and sailed it out to the reef, getting in a bit more sailing practice as I went. I made a mental note that I should probably make a more robust anchor for it, because I was worried about the pile of rocks I've been using not being adequate to resist the force of the wind on the boat, even when the sails were furled up. Nevertheless, I eventually convinced myself the anchor had a good hold on the bottom, and gently lowered myself and my explosive scuba gear into the water. I slowly followed the anchor rope down to the bottom, as a test of how well the pressure compensation balloon worked. As expected, it had a tendency to try and float me and the breathing apparatus back up to the surface, without tying a bag of rocks to my own waist. However, I quickly forgot all about the test as I became enamored with the beauty of the reef. The shimmering lights on the pastel corals, the flitting, colorful fish, and the dark crevices underneath begging for exploration. I lost myself down there for nearly an hour before I started feeling hungry and remembered it was time to head back to shore. The rebreather worked like a dream, so I sailed back and had lunch, feeling quite satisfied. I brought some coral and sponge specimens back with me from the reef and spent a little time drawing and describing them in my notebook on aquatic fauna until the kilns were done cooking the dive suit and armor plates. I gave them some time to cool, and myself some time to finish my writing, before beginning the process of attaching the tiles to the suit. It was slow and tedious, taking me most of the remainder of the day, but the result was pretty spectacular. The tiles give the suit almost the appearance of fish scales. I couldn't resist putting on what I already had, and looking at myself in the mirror. The compressed air tanks in particular looked like some weird, stony sea urchins had attached themselves to my back and pulsed slowly as I breathed in and out like some kind of alien parasite. Suitably jazzed, I found a place to hang the heavy suit before going to bed. Week 32, Day 5. When I got up in the morning, I checked on the helmet that I had left electroplating since Day 2. The original plates had since dissolved away completely, and the helmet itself was, as far as I could tell, a couple of millimeters thick, but according to my calculations, that was all I needed. I removed the helmet from the electrolysis tub, dried it off, and packed it in coal before loading it into the kiln and starting a fire around it to begin case hardening it into steel. I then proceeded with my morning chores and kept the fire around the helmet stoked throughout the day. When I came back, I was again a little surprised that I'd somewhat run out of things to do with the diving suit project. I didn't think I was going to finish before the end of the week at all, let alone have spare time on my hands. So, I let my mind wander a bit, back to the subject that had started me down this rabbit hole in the first place, namely defenses for the next presumed smuggler attack, which I assume is coming up soon. I'd been having so much fun with the diving suit that I'd kind of forgotten about it. One thing that comes to mind is a solution so simple I frankly feel stupid for not thinking of it the first time my base was attacked, which is simply putting a gate at the main entrance of the compound, on the south side facing the beach. I mean, I was able to make a fence and gates for the garden, and locked doors for all the buildings, but not one big locked door to protect all the smaller ones? How foolish. In my defense, though, that path was a lot more open back then, and the pathway has since been crowded in along the sides by bamboo, at least the bamboo I haven't cut down. A gate there wouldn't protect the beach hut, but let's be honest, I hardly use it anymore anyway. It probably wouldn't be too much of a deterrent to people with big guns who might be able to shoot it apart if they wanted to. Still, that's going to alert me to their presence and make them waste precious time and ammo. A gate wouldn't really be so much to protect me anyway, as to protect all my stuff from being messed with, as, in an emergency, I'm probably not going to leave the house anyway, and if I need to, I have plenty of options. As such, the gate hardly even needs to be contiguous, since they could shoot through it if they wanted to, just grated enough to keep a person from getting through. Furthermore, I wouldn't want the gate to block the beams from the dazzler and acoustic array, otherwise it would kind of defeat the point of them, so a simple grate gate will probably suffice for now. I headed out and cut down some bamboo not involved in forming the protective hedge around my base, and then began construction of the gate, beginning with some doorposts with triangulated members on the sides to make them sturdy, as well as to make it harder to get around them through the surrounding bamboo grove. Hard enough for me to install them at any rate. I dug some holes around the main post and filled them with concrete to make them extra secure. For some reason, I thought it looked nice to put a little crossbar between the posts high up, but at the same time, I didn't want it to be too stylized or ostentatious like some big oriental gate, which wouldn't quite match the look of the rest of the base. Frankly, I think that was another reason I was kind of low-key avoiding this. Gates like these always reminded me of rich people houses, or gated communities, and they were always so fancy that they rubbed me the wrong way, so I didn't really want to emulate that. Nevertheless, once I'd gotten the posts up, I started working on the gates themselves, opting for a pair of gates in case I needed to get something big in or out of the base, like the catamaran if I decided I need to put it in dry dock or something crazy like that. Again, I didn't opt for anything fancy, just a couple of square frames with some vertical posts tied onto them. But since this gate was also meant to be a defensive structure, I also made those posts extend above the frame and used my axe to make them sharp at the ends to discourage climbing. I then mounted the gates to the posts using rope as a simple hinge, though using enough of it as to make it impractical to just cut or hack through with a knife or machete. I was a little surprised at how light the gates were, but that's bamboo for you. Even so, since I like to over-engineer the heck out of things, I took a little extra cord and tied it along a diagonal to the inside of the gates to provide a little extra support. Finally, I made some crossbars to lock the gate, and while I could have put in another complicated puzzle lock here, as much as I would have loved to, I think that if I was in a situation where I needed to shut this particular gate, I wouldn't want anyone to get in from outside. I'll either already be inside, safe and sound, or I'll have secret back doors to get in through, which already have puzzle locks on them. So I just made the crossbars extra beefy. However, because this was supposed to be a defensive structure, I did have an idea for one trick. I've learned a few things about how medieval castles were built, and was always particularly interested by the way the windows were designed, namely so that archers could easily shoot out at any angle, but not in. Neither this gate nor the nature of firearms is necessarily going to lend itself to that exact design, but what I did have the idea for was to put a hole in one of the posts and give it a lever on which to rotate it, which could only be accessed from the inside. The idea is that I can stick my gun through this hole and open fire if I need to, while using the same hole from the outside should be next to impossible. I started varnishing the gate at that point to waterproof it, and stopped for lunch before finishing the job. By that time, I figured the helmet had finished case hardening, so I removed it from the kiln, doused it in water to cool, and did a bit of grinding with a rock to take off any sharp edges, and to make a nicely shaped surface for the glass panels to adhere to, specifically so that the glass panels would be a little bit inset to the metal, though the glass was actually much thicker. I then applied latex around the inside and outside edges, and a liberal amount to the frame that I tied on to hold them in place. It was almost a shame to cover up the iridescent oil-like swirls on the otherwise blackened steel surface, but I was more concerned that the helmet would rust if exposed to seawater, so I went ahead and painted the entire thing, inside and out, with latex as well, which would also help it keep a better seal against the neck of the diving suit. This was more or less the last component for the diving suit, which was exciting. I just need to make a whole load of potassium superoxide tomorrow to fill it up, and I haven't even stopped the bubbler this whole time, so I have plenty of potassium peroxide to work with tomorrow. Still, I found myself at the end of the day with a couple more hours to kill, and while admiring the gate once again, I decided there was one more thing I wanted to do with it, and that was to just build a simple roof over the top of it, in case I needed to open or close it in the rain. Not essential, but convenient. So I removed the crossbar and used some spare lengths of bamboo to convert it into a triangular frame, before lifting it back up on top of the posts, and used some short bamboo scraps for shingles. It looked nice when it was done, and I decided to give it one more aesthetic touch by hanging a couple of lanterns from it. As the sun went down, it made the gate look just that much more inviting. I don't really do a lot in the compound after dark, but this makes me think that I might do more if I had some light, so I'm considering making some street lamps, or at least tiki torches, tomorrow. Week 32, Day 6. I got up and loaded my potassium peroxide straight into the pressure cooker first thing in the morning. There was a lot more of it this time, both in the tubes and on the floor of the pressure cooker, meaning it may not diffuse all the way through the thicker layer of powder. Then again, the stuff on the bottom will also be the hottest, and therefore perhaps the most likely to react as well. Either way, I set it up and got started on my morning chores, and when I returned, I decided to start working on those lamps. I only made a couple the first time, just enough to light the insides of my buildings to a level of bare adequacy. So this time I made more, again using clay to make little pots to hold methanol and wicks, and because these would be sitting outside, I made little conical hats over them to keep the rain and wind off, but also to direct the light down and out. I left them to sit in the sun to dry for the day. Firing will have to wait till tomorrow. In the meantime, I also made some bamboo posts to rest them on, going all around my base, from the entrance, lighting the path around the central solar tower, to each of the buildings, and back again, creating a sort of main street from the gates. I also made several posts to illuminate the garden and amphitheater, which will look magical at night, and I'm planning on having one that'll hang from the inside of the arbor in the center. Just imagining how it'll look when it's finished, it makes the compound look more like a small, quirky town than the distributed abodes of one man, which again makes me feel a little less alone somehow. At the same time, however, the thought of having all those lamps around also made me a little nervous, as they pose a significantly larger fire hazard, basically a bunch of Molotov cocktails waiting to happen, which is why, as much as I wanted to for my growing aesthetic craze, I didn't build any lampposts outside the gate, because I didn't want to give the smugglers any ideas, much less ammo. This got me thinking about making some kind of fire alarm, or even fire suppression system, just in case my buildings do catch on fire, purposefully or not. I spent some time thinking about this, and there are a couple of specific properties of fire that are normally detected by smoke detectors, but would be very difficult for me to replicate with the equipment I currently have, namely increased temperatures and the presence of smoke. It's hot enough here as it is, and I figure that if there's a fire in the middle of the room, by the time a thermometer realized anything was wrong, it would probably already be too late to save anything. That leaves smoke detection. Most smoke detectors use radioactive americium to ionize the air around them to basically determine its composition, and if it detects even a hint of smoke or soot, like what comes off your toast before it even starts getting crispy, it sets the alarm off. I don't have access to any radioactive materials, obviously, nor do I think I'd want to, as it seems both dangerous to my health as well as highly wasteful of an incredibly valuable material. However, it did occur to me that back home when we were using a wood stove, that soot tended to collect on the walls over time. That soot was mostly made of carbon, and as we all know by now, carbon is electrically conductive, so that would give me a way to potentially detect its presence. Furthermore, a lot of my stuff is now coated in a sap-based varnish. While this makes everything more flammable, it also produces a thick smoke, kind of like incense, which would be easier to detect. This gave me some ideas, so I went back to the lab and started doing some experiments. It was easy enough to create a smoke detector by putting a couple of copper sheets or wires next to each other and lighting a lamp underneath them. Soot builds up in the gap between them, eventually closing a circuit or creating a measurable resistance on my ammeter. However, consideration also needed to be taken to the fact that other things might mess with this sensor, like dust buildup, which shouldn't conduct electricity and may eventually plug up the sensor, or water from rain or humidity, which would, potentially setting the detector off by accident. I did a little testing though, and found that, because carbon is much more conductive than water, there's a certain threshold resistance I could use to tell them apart, short of the detector being completely submerged of course, which seemed unlikely in most cases, as they'd be hanging from the ceiling. One thing I could do to help force rapid detection, though, would be to take advantage of the fact that smoke will tend to rise and leave buildings in a specific location, especially since I built most of them like smokestacks already. Then by putting baffles on the detector, I can create dead zones of slow-moving air next to the detector, where soot will be encouraged to collect. What I ended up coming up with was a sort of bamboo funnel to go on the tops of many of my buildings, with coils of wire on the inside, close together but electrically separated, and using the many otherwise discarded bamboo partitions to make the baffles. Now that I had a detector, I needed to figure out a way to make that electrical signal useful for putting out fires, specifically for opening something like the nozzle of a sprinkler. This was again a hard thing to figure out how to do without stuff like electric motors to turn electricity into mechanical energy, and I thought about this problem a bit over lunch. Again, I didn't want to waste wire on motors, not that I had the iron for them anyway. The only other thing I could think of was something like an electromechanical switch, like those used on circuit breakers. The idea is that you put two different metals together in a strip, and when an electric current passes through them, they heat up, expanding at different rates, causing the composite strip to bend. That would be enough to open a simple valve. I didn't entirely like it as an option because it was energy wasteful, but I didn't think I had any other options. Another issue with this, though, was that I didn't really have any other metals available to me to make the switch with. I went all in on copper. I didn't think that needed to stop me, though. If I had a valve being held open with a spring or water pressure, and used a small piece of wire to hold it closed, heating the wire with electricity would cause it to become soft and allow the valve to open. Might waste the wire, but truthfully, this isn't going to happen often, so it probably won't be much of a waste. Just a little insurance. Furthermore, a thin wire wouldn't need very much current to get hot, as evidenced by my light bulbs, so I could run these things with zinc batteries. Again, feels a bit wasteful, but I wasn't using the batteries for much else anyway. With that figured out, after lunch, I started experimenting a little with making a nozzle for my fire sprinkler system, which consisted primarily of two nested pieces of bamboo attached to the end of a hose, one of which had some holes drilled in the sides. I held it closed with a rubber band, and water pressure from the hose pushed it open, spraying water in all directions. I then took a piece of wire and heated it over a lamp flame to get it hot enough for me to pull into something thin enough to make a good heating filament, and at that point I realized I could save the filament after all. The filament itself doesn't need to be the thing holding the sprinkler head closed. I could use something stronger, like a piece of cord or string, and let the filament burn through it. I guess you could say that's fighting fire with fire. Once I was satisfied with my design, I started mass production, making a batch of new hoses to line the ceilings of my buildings with, and machining several sprinkler heads from my many bamboo partition scraps. My round buildings, like the kitchen and lab, really only needed one sprinkler each. The house, workshop, and bathhouse needed two each, because they were rectangular. I made a couple extra for the gates, because they were the logical places to try and set fire if you were trying to get in. I wasn't worried about the bamboo hedge itself being burned, though. One, because there's water constantly dribbling on it from my little trough system, and two, the green bamboo wood would be hard to burn anyway. I realized, though, that the one building that had the most water, and the most likely one to catch fire, was also the hardest one to build a sprinkler system into. Most of the buildings would be relying on the water pressure created by the solar tower to pressurize their sprinkler hoses, but that pressure won't be present at the top of the solar tower itself, where the burning hot kiln is. Not that there was anywhere for me to put a smoke detector up there in the open air anyway. I made some for the intervening levels, though, as the support pillars and elevator were the most vulnerable. Thinking about it, I realized that, if worse came to worse and the top of the solar tower caught fire, I could probably use the bellows to pump water up from the cistern below to put out the fire. I would probably have to do this manually, but on the off chance it would save anything or any time at all, I made a custom sprinkler system for the solar kiln. It consisted mainly of a ring of hollowed out bamboo with holes in it that'll mostly dribble water onto the kiln's support columns and where the reflector panels connect to them, and a rotational valve that would be pulled open with a rubber band but is held closed by another string and heating coil. Because this machine was out in the open air, I made several smoke detectors in places where I expected smoke would rise from the structure, rather than the kiln itself where things are supposed to be burning, but I was mostly hoping that one of them would get lucky during a fire, connecting them in parallel to a zinc battery, so that if one smelled smoke, all the power would still be shorted to the valve. By the time I was done with this, the sun had started going down, so I cleaned up after myself, leaving the hoses to dry overnight, and got ready for bed. As I did, though, I thought about how the roof over the gate also needed to be varnished. Week 32, Day 7. I'd almost forgotten about the diving suit, getting distracted with the fire suppression system for the base, but not by much. When I got up in the morning, I collected the presumed potassium superoxide and loaded it into my diving suit. It wasn't much, about 4 cups, but it was enough for an extended dive later in the day. For the moment, though, I loaded my rubber hoses from the other day into the pressure cooker to vulcanize before starting my morning chores. I then worked on my transcriptions and listened to my weekly sermon, but it was hard to concentrate with the prospect of the dive on my mind. As soon as I was done, though, I headed straight for the flooded tunnel and put on the diving suit. After conducting extended tests to make sure there were absolutely no leaks, I pumped up the tanks until my weight wouldn't depress the pumps any longer, and waded cautiously into the water, again forcing myself to take my time in case of leaks. When everything seemed to still be working, I descended into the pool, the light from my headlamp illuminating the cavern walls and the halocline ahead of me. It still shimmered, but it also appeared to still be disturbed from the last time I swam through it. Not as clean a boundary, but fuzzy. Nonetheless, I carefully waded into the brine and made my way down the tunnel towards the blue light of the ocean. The weight of the clay tiles seemed to hold me down adequately, and I didn't feel over-encumbered. Unsurprisingly, there wasn't a lot living in the tunnel. A few starfish and urchins, a few small fish hiding or exploring the cave like me, but that was about it. I soon found myself at the edge of the hole, and because it was surrounded by coral that had grown in and around it, I had a little difficulty climbing out. Once I did, though, I took my time exploring the reef, from the bottom up this time instead of the top down. The going was slower than scuba diving, but somehow, walking that way felt more natural. Although I could take specimens more easily at this point, somehow I found myself less inclined to do so, just to look at them, and it made me wonder if feeling rushed to see everything on a few small breaths led me to take more destructive behaviors by taking specimens from the reef before. As I explored, I began to realize just how massive an environment the reef actually was, far bigger in area than the island itself, or so it seemed. Eventually, though, I found myself at the edge of a precipice, more like a steeper incline, where the coral stopped growing, and I noticed how actually dark the water had become. Looking over the edge, I could see scattered weeds and echinoderms, but that was about it, fading out and downward as though obscured by an indigo fog. I felt eerie. It's not like on land where you can see out to the horizon. Here, that horizon is obscured by a veil of unnatural darkness with who knows what leviathans lurking just beyond it. It sent a chill up and down my spine that I wasn't expecting, exploring the colorful and seemingly safe reef moments before, so I turned back, feeling vulnerable and yet somehow strangely tantalized by what wonders and terrors might live in that darkness. I should point out that nitrogen in normal air becomes dangerous above 2.5 atmospheres, which is equal to about 25 meters underwater. This is well within my diving range, and the coral reefs seem to grow poorly below 18 to 27 meters. If I ever wanted to dive deeper, I would need to replace the nitrogen with something else, like helium. Even if I did go below my safe depth, the slowness of my walking in the diving suit would probably give me plenty of time to decompress. I returned to base, exhausted from my undersea walk, but still electrified by it. I couldn't help but notice, however, the oppressive heat of the island again, which I'd almost become accustomed to. I guess I'd almost forgotten about how good it felt to be cool, and the ocean's embrace all around reminded me of that. I'm looking forward to doing that again. By the time I was done with lunch, though, I figured the hoses were done vulcanizing, so although it was Sabbath, I worked on installing the new fire sprinkler system, which used up most of my batteries. It occurred to me, though, that the light buildup of char or water on the detectors over time could cause a small current to flow. Not enough to heat the coil, but enough to drain the batteries, so I'll have to make it part of my monthly maintenance routine to clean the detectors and make sure their batteries are charged. Installation took a couple of hours, but now I could at least rest easy knowing that my base was pretty much fireproof. I spent the last couple hours of the day writing and drawing in my nature books about new species I found on the reef, doing my best to draw them from memory, but doing so lightly in case I needed to change the drawings later. The blooper reel, ba-da-da-da, the blooper reel, ba-ba-ba-da. I'd bet you money, that's where it's funny, see the appeal. Asyle. Tropical Island Survival. Week 32, Day 1. There's something in my ear that itches. Con! However, I found that I couldn't find... Getting back out on the boat, seeing the reef below through the... How are we doing this time? You good? Good. As would be the case if I were just venting my CO2 like with scuba deer. Scuba deer, there's a mental image for you. But little, if any of the water should... That's hard to say. That I could still hold on to with my lips and teeth in case something went wrong. There's a typo I need to deal with. I remembered calculating a long time ago for a different project. I was designing a spacesuit for my own amusement. That a quarter cup of potassium peroxide would give... Hold on. I think I heard a cat. I assume if the cat is loud enough for me to hear through my headphones, it's probably loud enough to ruin the recording. Now, where was I? While still allowing air to flow through them freely. My throat tickles a little bit today. I heard a horrible joke. Someone told me that Norwegian ships have a QR code on them, so that when they come into port, they can Scandinavian. So I took what impure potassium superoxide I had to begin test... How do I say this sentence? Why do I keep writing weird sentences? In the meantime, I decided I needed to... and effectively exercise my intercostal muffles and used a rubber membrane with a small float glued to it. That's another weird thing to say. But a larger I enunciated so hard my head hurts. What I came up with is a couple of that should be a was, not an is. Pause. I designed the viewports in my helmet to follow a hexagonal pattern. Another thing I did was make sure there was room inside. With that determined, I loaded the powder and a fraction of the mountain. Okay, I need to edit that. Which were now ready for backing. I think I meant baking. I've also trying to stock one typo after another. Oh, the gated community is where we like to be. Our clothes are never dirty and the grass is always green. And when you come to visit, you can stand outside and see what a lovely bunch we are in our gated unity. Finally, I keep running into typos. Now, after that long break, where the heck was I? Finally, I made some crossbars for the... I'm sorry. Let's go back a little bit more. But what I did have the idea. Okay. So I went ahead and painted the entire thing, inside and out, with latex. Most smoke detectors use radioactive americium. Then by putting baffles on the detector and heated it over a lamp flame to get it hot enough for me to pull into something thin enough to make a good heating. Air, please. I didn't entirely I didn't entirely like it as an option. I feel like that needs some editing. Shoot, that was a long one. Hey there. Thanks for listening all the way to the end of this deep dive. I'm looking forward to doing some more exploration of the reef in coming weeks, but I'm afraid that I'll probably have to deal with the smugglers first. And although time is running out, there are still a few more things I can think of to try and make myself ready for them. So, if you want to see how that turns out, you can press the subscribe and bell buttons to get notified when it all goes down. Now, I'm not diving for treasure with these videos, no ads, no Patreon. But it would help me out more than anything else if you could share this video with someone who you think would enjoy it. And since you enjoyed it enough to watch it for this long, you can press the like button to say so, and to tell the algorithm to do some of that sharing for you, since it still seems to consider me a nobody. Also, if you want to chat about your own stories and perspectives on the episode, maybe some experiences you've had scuba diving or working with chemical rebreathers, please feel free to share them in the comments section below. I genuinely love to hear them, and I'm always open to suggestions and corrections. That said, thanks again for listening, and hope to see you here again next week.